Alright, so we're going to work through the train problem here. So, we've got two trains. The train leaving Central Station, this one right here, that's our train, and this is the other train. So our train, passes another train that left North Station at the same time. So both trains leave at 1:10 p.m. They pass each other at 2 p.m., and our train arrives at North Station at 2:30 p.m. So for right now, we are going to ignore this train. We're only going to focus on our train and how it travels from here to North Station. That's going to be our entire focus for the first part of the problem. So from 1:10 to 2 p.m. is 50 minutes. From 1:10 to 2:30 p.m. is 80 minutes. And that's just math facts there. Now, by dividing those by 60 minutes in an hour, we find that these simplify. 50 over 60 simplifies to 5/6 of an hour. 80 over 60 simplifies to 4/3 of an hour. It's a little over an hour. Or 1 1/3 if you wanted to put it as a mixed number. But the improper fraction will do better for us in this case. Now, we know our train traveled 200 miles between the two stations, and it took it 80 minutes, which is 4/3 of an hour. So that's the time our train took to go from Central to North Station. And we know the distance between the two stations was 200 miles because it said so here. With that, we can use our equation, d equals rt, and this is what you did last year. And we can calculate the speed. So I used some algebra, and I went ahead and divided everything by t on both sides of the equation. So I ended up with r is equal to d over t. Like that. And that's what it gave me here. I then plug in my values. The distance is 200. The time is 4/3. The miles and the hours I'm going to put over each other like this. 200 I'm going to put over 1. When you divide by a fraction, you flip and multiply. I do that. Cancel here, I get 50. 50 times 3. So that'd be what here? That'd be 1. That'd be 50. 50 times 3 is 150. So we're traveling at 150 miles per hour on our train. We've already finished half the problem, and that's the half that we need to get to the interesting part. We were told to find the speed of both trains. And to do that, we're going to need to spend a little more time. So we know that train 1 has a rate of 150 miles per hour. With that information, we can find out how far it went before it passed the second train. So what we want to do is at some point at 2 p.m., the two trains pass each other. And we want to know when that occurs. Or not, I should say, what distance that occurs. So here, at 2 p.m., the trains pass each other, and I want to know what this distance here is. That's the distance of my train at 2 p.m. And we can find that. Now that we know the speed and we know the time, distance is equal to rate times time. Distance is equal to rate times time. My rate is 150 miles per hour. And my time, well, we said just a minute ago that was 50 minutes. So now we just do that calculation. So we have 2 zeros. 5 times 5 is 25. 5 times 1 is 5 plus 2. So something went wrong there. Oh, we mixed our units, didn't we? My apologies. We needed to switch that to 5/6 because we needed in hours. It's 150 miles per hour. Let's put the units in there so we can see why that's a problem. There we go. We need hours to cancel with hours, so we're left with miles. So now, let's see. 6 fits into 150. 6 fits into 15 twice, with a remainder of 3. It fits into 35 times. 25. So 5 times 5 is 25. 5 times 2 is 10. So we've traveled 125 miles. So now we know the distance traveled by my train. We know the total distance from here all the way to here That is 200. So the other train, take 200, and we subtract the distance my train has traveled. The other train must have traveled that distance, or 75 miles. It's been traveling the same amount of time. It's been traveling for 50 minutes, but it's only traveled 75 miles in that time. So now we go for the distance and the rate of the other train. We know it's traveled 75 miles. We want to know its rate, and we know there's been 5/6 of an hour. Well, we can divide by that fraction, which is the same as multiplying by 6/5. We do need to divide by hours, though, because we want the hours to cancel out here. These cancel, these cancel. If we do it to one side, we have to do it to the other side. So hours on the bottom, 6 on the top, 5 on the bottom. With that, 5 fits into 75. Let's see. Once with a remainder of 2, and then 5 times, so 15. 6 times 5 is 30. 6 times 1 plus 3 is 9, so 90. And we have miles here. Divide by hours. Miles per hour. So the speeds of the two trains have been found. So this up here is pretty basic. We figured out the times. We converted those to hours. We threw it into an equation and we solved. Down here is where it got interesting. We had to use something we found, and then we had to use the original problem and rethink how that setup was done to find this one. And I'll tell you what, none of this is above your level. You all know how to work problems like this, but what it requires is creative thinking. When you look at the problem, it doesn't plug into any formula you know. You have to work out and reduce it to parts that fit into the formulas you're familiar with.